Group 11 from Fluid Mechanics Session 2. We are going to introduce our final project is bending pipe and over pressure under pipe. I am Imran bin Muhammad Abinuddin.
I am Muhammad Fitri bin Hassan.
I am Muhammad Khairudin bin Muhammad Kasim.
I Ahmad Ashman bin Mak Idris.
I Muhammad Amir Asraf bin Asuki.
I Muhammad Luqman bin Ibrahim.
Enjoy. Okay, so we going to discuss about your final project. Okay, what your topic about?
Our topic about the leakage occur in the pipe.
Oh, leakage in pipe. So it's relate about in bending pipe lah also.
Yes.
Okay, so the fact one is there is a leakage occur on the pipe caused by the excess pressure, is it?
Yes.
Yes. So what your opinion about it?
In my opinion, the leakage occur on the pipe is because of the overpressure on the pipe. That's why the pipe cannot resist the pressure, so the leakage occur.
Oh,
So that in our project, we need to determine the max pressure
max
that
pressure.
the pipe can exist.
Oh, okay. Oh, so that's it. What about the exit force on the pipe at a certain angle? So we have an angle, isn't it?
Yes.
For the bending pipe also we have the angle. So the certain angle is what you are using for.
In my opinion, the angle have its own what we call effect on the
Effective angle.
effect of angle to the force.
Oh.
So that we need on that particular angle, we need to determine the exact force on the pipe.
Oh, I see. So the angle will relate
Yes.
with the force.
Yes.
And now guys, we want your guys present about actual and calculation bill.
Okay, first one. We know the actual pressure in the pipe is 7.5 exponent 10 power of 6 Pascal. So I will show to you guys how we calculate the pressure in the pipe. Okay, firstly, we find all the value constant in the pipe. First one, the flow rate of water in the pipe, which Q 0.1 meter cube per second. The height of pipe 1 meter. The pressure of pipe 7.1 exponent 10 to power of 6 Pascal, and the diameter of the pipe which 0.2032 meter. Okay, so we will start to find the velocity and the pressure. From that we make the comparison, which the actual value that we must to get and the calculated value that caused the leakage. Okay, firstly, we find the velocity. We use formula Q equal to AV. Then we find the velocity V equal to Q over A. We put the value which 0.101 over 0.032. Then we get the answer 3.16 meter per second. And the calculated value from the pipe is 3.16 meter per second. Okay. Then we will find the pressure from the actual value and calculated. From the actual value we use Bernoulli equation, which pressure 1 over rho g plus V1 square over 2g plus Z1 equal to P2 over rho g plus V2 square over 2g plus Z2. Okay, we put all the value, then we will get the value of the P2, which 7.09 exponent to power of 6 Pascal. And then the calculated value, we get the 7.49 exponent to power of 6 Pascal, which the value is more than the actual value that we must to get. Therefore, from this value, we know this is the cause make the pressure in the pipe burst.
Then for the determine resultant force and direction, we will use application of momentum equation for the actual and calculated. We find the Fx for the actual and Fx for calculated. First we find Fx for actual. For the actual, Fx equal to P1 A1 minus P2 A2 cos theta minus rho Q V2 cos theta minus V1. Then we substitute the value for the Fx. Then we find 53474.669 Newton for the Fx of actual. For the calculated, we find 57449.674 Newton for Fx calculated. Then we find Fy for actual. We get 164,270.262 Newton for the Fy actual. For the calculated Fy, we get negative 173,526.403 Newton for force in Y calculated. Then we substitute in the Fr formula, we get 172,754.91 Newton for the actual Fr, and for the calculated Fr we get 182,789.16 Newton. Then we find the direction using tangent theta equal Fy over Fx. Then we find for actual angle we negative 71.96. For the calculated we get the angle negative 71.68. Okay, for the conclusion we get the Fr of calculated is bigger than Fr of actual. Then that's make the pipe will burst and leakage of the pipe.
Okay, guys, we are going to end of the forum. So now I want to you discuss what we are going, what we get about the your final project.
So for the discussion, we can conclude that the leakage is caused from the overpressure
Overpressure.
water from in the pipe.
Oh, I see.
Okay.
And then,
As a conclusion,
yeah, what you conclude?
we can conclude that from the pipe distribution,
Yeah.
this pipe distribution, the water pressure must not exceed the maximum pressure.
Oh,
Okay.
so
So if we get the value more than actual value, the pipe will leakage.
burst or leakage.
Yes.
So that your conclusion, and what you guys can be suggestion for the next project.
Okay, in my opinion, I think we can use the other material that more high quality from this material.
High quality material, and then
For me, based on the solution that we get, we need to use the pipe that have the bigger size of diameter and have the thicker
Thickness.
More thickness.
Yes.
yes. So you use large more diameter of the
Yes.
pipe because the amount of water
To overcome the problem.
to overcome the problem, and then
More thickness.
more thickness. So that's
Bigger
all.
thickness.
Bigger thickness.
Yeah.
So that's all. Okay, that's all for us. So